Hello class, in this video I'll be discussing mole concept, Avogadro's number, mass-mole particle relationship. Okay, let's start. So first we have to define the term mole, describe the relationship between this quantities, and then of course solve problems involving mass, mole, and particles in a substance. So this is under the branch of chemistry, which is stoichiometry. So when we say stoichiometry, we're looking into the relationship between the reactants and products in a chemical reaction. So you will know the needed reactant or the product that will be formed by computing the substances involved, okay, to determine the desired quantitative data. This concept is very important in experimentation, so that you will also save certain amount of substances or chemicals. Okay, so if you're expecting to get a certain amount of product, you have to calculate the amount of reactant needed to get the certain product. Okay, so para maiwasan din yung mga nasasayang na substances, at the same time, you will also know the limit of the reactions, okay, or the actual amount of chemical that will be used. Okay, so that's one important application of stoichiometry. So mole in chemistry refers to the amount of substance that contains elementary entities such as atom, molecules, and other particles. So we already know that these atoms, molecules are very tiny, so they are huge in number. So one convenient way to express this quantity is using moles. Okay, so I'm using the grains of rice as an analogy. Okay, we put this rice in a sack of rice. Okay? This sack of rice will be equal to 1 mole. Okay? Parang siya yung 1 mole. Analogy lang ito. Okay? And the number of grains inside, okay, refers to the number of atoms. Okay? Pwede rin siyang atoms, pwede molecules, grains. But the number will be the same if we're talking about 1 mole of a substance. Okay. So, and then, of course, it will have its mass. And the mass depending on what kind of grains are inside. So, pwedeng, that could be rice, pwede rin namang wheat, pwede rin namang cereals, and so on. Okay? So, it's a convenient way to express quantity, again, because these particles or these entities are very small. So, we put them together. And then when we're talking about 1 mole of a substance, then we're pertaining to the same number of atoms. Okay? It's like putting them in a basket. Okay? One basket is equal to this number of atoms. Okay? So the value that was discovered, okay, during their computation is that for every 1 mole of a substance, there is 6.2022 times 10 to the 23. Okay? So for every 1 mole of a substance, we have this 6.022 times 10 raised to 23. How huge is that? So this is the exact number. So for every 1 mole, so that means we have this number of atoms, molecules, or particles. Okay, so that's why we express this in scientific notation, because that's very huge. Times 10 raised to 23. Okay, or ions or substance. So that will be our constant value. 1 mole of a substance is equal to this. Okay, they will differ in terms of mass because this would involve different elements with different mass. Okay, but basically that is 1 mole of a substance. Okay, this was discovered by Amadeo Avogadro. Avogadro. Okay, that's why it's called Avogadro's number, which is 6.022 times 10 raised to 23. Okay, so he used the actual number of carbon 12 to determine how many atoms are there inside 1 mole of a substance. Okay, take note also that moles and molecules are not the same. When we say molecules, this refers to the compound. Okay, when we say moles, this is substance. Okay, amount of substance, and that refers to the number of molecules, number of atoms or molecules. While compounds are like H2O, CO2, and any other compound. Okay. Molar mass refers to the atomic mass of the element per mole. So the unit will be gram per moles. How many grams per 1 mole of a substance? Okay, that's why it's molar mass. It's grams per mole. The term molar mass is a general term for formula mass, molecular mass, or atomic mass. But all of this refer to molar mass, okay? Amount of substance or amount of compound in grams per mole. When we say formula mass, this is the term for the mass of ionic compounds, molecular for covalent compounds, and for atoms, we have atomic mass. An example, what is the atomic mass of carbon? Okay, so carbon, you look at the periodic table, so that will be 12 grams per mole. This is atom, so it's called atomic mass. Okay, let's have carbon molecule, okay, which is a covalent compound, CO2. This is covalent, so this is called molecular. Okay, so that will be 12 plus 2 times 16, 32. This is 1 times 12, so 12. So 44 gram per mole. Okay. Then for ionic compound, we have here formula mass. But basically, you're just doing the same thing. Okay, so let's practice molar mass. We'll stick to 2 decimal places so that it will be easy to compute decimal places. So here, you will be needing periodic table element. Let me get my periodic table first. Let's answer this. Find the molar mass of sodium carbonate, Na2CO3. So the subscript tells you this one tells you the number of atoms. Okay, and if there's no subscript, that's automatically 1. So you first list down all the elements. So we'll have here Na, C, and then O. Then multiply by the number of atoms. So we have 2, 1, and 3. Again, this is the subscript, 3, 1, and then 2. Then you look at the periodic table to get the mass. We'll use the whole number. So for sodium, that's 23. Carbon is 12. Oxygen is 16. Then multiply. So we have here 46, 12 plus 48. Then add this together. Of course, I'll compute 46 plus 12 plus 48. So that will be 106, and the unit is grams per mole. Okay, so there. Oops. Okay, next. Let's try this. Find the molar mass of acetic acid. So if in case that the elements are appeared to more than once, then you just count it also. So we have CHO. For carbon, we have 2. This is 1 and then 2. For hydrogen, we have 1, plus 3, so that's 4. And then for oxygen, we have 2. Multiply by the mass from the periodic table. So 12, 1, and then 16. So this one will be 24, 4, and then 32. Add this together, 0.60 gram per mole. Okay, so there. Next, let's try this. So you'll be familiar with the mass of the elements that we usually use. For example, this carbon, it's 12. H is, okay, and then 11 multiplied by carbon is 12, 1, and then 16. Let's calculate 144, 22, 11 times 16, 176. Add this together, 2, carry 1, 11, 4, carry 1, 3, 342. Okay, 342 gram per mole. Okay, so if in case it's enclosed in the parentheses, you have to distribute this here to what's inside the parentheses. So there, you'll have Mg, P, and then O. So this one is 3, 2, then 8. Multiply, 16, phosphorus, 31, magnesium is 24. Solve, 72, 62, 16 times 8, 128. 2 carry 1, that will be 13, 14, 15, 16, 262 gram per mole. Okay, so in this case, 263, due to some of the maybe due to using the whole number. Okay, there. So that's basically molar mass. Now let's talk about mass mole particle relationship. Okay, so this time we'll be converting from mass to mole to particles. It's like conversion of units. So take note that when you are converting grams, or which is mass, to mole, you'll be using gram per mole or mole per gram. So this means you have to use the molar mass. Okay. While if you're converting mole to atoms, molecule, particles, or formula units, you'll be using Avogadro's number. Okay. So you just have to check how to convert. So in converting, remember that we write what is, okay, so 1 should be cancelled and then the derived, so conversion. So for you to convert, you have the given to desired unit, right? So you have to multiply that given unit multiplied by the given unit over the desired unit. So that 1 will be cancelled, this will be cancelled, and you arrive with the desired unit. Okay, and this part is called conversion factor. So you'll need a conversion factor. And that conversion factor in mass to mole to mass, and atoms is either the molar mass or the Avogadro's number. Okay, let's have a quick example. So for you to convert 20 days to minutes, you need certain conversion factors. What will that be? So we have to multiply 20 days. We have to cancel the days. So we'll have here days and then hours. Because we know that in every one day, there is 24 hours. And then, for us to convert that to minutes, we have to put hours here, okay, or R, so that we can get minutes. And we know that 1 hour is equal to 60 minutes. Okay, so now we can cancel out the units, days, day, R, and the answer will be minutes. So this example, that will be 20 times 24 times 60 divided by 1 is 28,800. Okay, so basically you are just converting. This is your conversion factor. Okay, hours to days and minutes. So that is what we will do here also. So for mass to mole and particle relationship. So for you to convert grams to mole, you'll be using molar mass. Okay, so here, molar mass. If you're converting this or vice versa. If you have mole to atoms, you'll be using Avogadro's number, which is the 6.022. Okay, and if you will be converting grams to moles to atoms, then you have to use both molar mass and Avogadro's number. Okay, let's have an example. Okay. So iron corrodes to form red-brown rust iron oxide. How many moles of iron oxide contain 85.5 grams of pure iron oxide? So step 1 is to write the given. So that will be convert 85.5 grams of Fe2O3 to moles. Okay. Okay. So because you are converting gram to mole, you will use molar mass. Okay. So that means we need a molar mass. Let's write the given. So 85.5 grams of Fe2O3. Or we can skip this one for now, but later on we need that. So this should be grams per mole. Okay. But what will be the value? So we have to use molar mass. Molar mass. That will be solve. Okay, so you have to solve first for the molar mass. Let's move this one here. Molar mass of Fe2O3. Okay. O is 16, and then F is periodic table of elements. That will be 56. So 16 times 3, 48. 56 times 2, 112. Then add this, 160 gram per mole. Okay, so automatically we have 1 mole and then 160 here, so that we can cancel out the grams. So we're left with moles, so the answer will be, if you put that in a calculator, that will be division 85.5 divided by 160 or times 1, but it will have no effect. 0.5 divided by 160. So that will be 0.53 moles of Fe2O3. Okay, so that will be the answer. So in this case, you're just converting grams to mole, so you will be using molar mass. The unit gram is in the denominator so that you can cancel this. You're left with mole. Okay, so let's have another example. How many atoms are there in 11.3 grams of Pb? So the required is to convert. Okay, the given is in grams. You have to convert this to atoms. Grams to atoms, use Avogadro's. Okay, you can't use Avogadro's number immediately. You have to find first the moles. So instead of grams to atoms, you have to move first to grams, to moles, and then to atoms. Okay, so there you'll be using molar mass. And then in this part, you'll be using Avogadro's number. Okay, so we write first the given. So I have 11.3 grams of Pp. This is just an atom, so atomic mass will have the atoms. So we write 11.3 grams of Pb multiplied by grams of Pb, then to moles of Pb. Then after we convert that, we have to multiply this by mole and then atoms. Okay, so we start with the molar mass. Avogadro's number. So for the molar mass, you just have to look at the periodic table. That's Pb 207. So for every 1 mole, we have 207 grams. Okay, cancel this. So mole, cancel the mole. And for mole, we have, for every 1 mole, we have 6.022 times 10 raised to 23. Okay, I'm just putting the labels, but anyway, you can skip that part. Okay, so to input that in your calculator, you can just multiply first the, okay, so let's input 11.3 times 6.022 times 10 to the 23 divided by 207. I'm not including the 1 anymore. So that will be 3.29 times 10 to the 22. So 3.29 times 10 raised to 22. And the unit is atoms of lead. So that's the answer. Okay? Okay. Let's have another one. How many molecules are there in 5.50 moles of glucose? So the given is in moles. We're looking for the molecules. Okay? Because there's no grams, so no need for the molar mass, we'll just use Avogadro's number. Avogadro's number. Okay? So we'll write the given immediately. 5.50 moles multiplied by, for every 1 mole, we have 6.022 times 10 raised to 23 molecules. Then cancel the moles. So we have molecules. So let's compute that here. So basically, you multiply 1.50 times 6.022 times 10 to the 23. So that will be 3.31 times 10 raised to 24. the unit is molecules. Okay, so there. Another example. Hey, how many atoms? Is this the same? I don't know. How many atoms are there in 256 grams of carbon? So that's grams. You have to convert that first to mole and then to atoms. So molar mass and then Avogadro's number. So 256. Can you have 20? 256 grams multiplied by molar mass of carbon. So carbon is 12 gram per mole. Okay, so that will be 12 grams here so that we can cancel 1 mole. Then mole here and then atoms here. Avogadro's number, so 1 mole, 6.022 times 10 to the 23. So cancel the grams, cancel the moles, we have atoms. So answer will be, so that will be 250 times 6.022 to the 23 over 12. So that will be 1.28 times 10 to the 25 atoms of carbon. Okay, there. Okay, the rest are almost the same. Okay, next, this is mole. No, the given is in grams to mole, so we'll be using molar mass. So you find first the molar mass. So 150 grams multiplied by gram per mole. So molar mass, so Fe2O3 56 16. I think we solve it. So we have 11248 160 11248 160 gram per mole. So we have here 1 mole and then 160. So that will be 150 divided by 160. 0.94 gram per mole. No, just moles. And the RMC. Okay, so for now, you are converting the same compound. Okay, but in the next lesson, you will be converting. You'll be using chemical equation to solve this. Okay, so you can practice more on this. Okay, good luck.